Hi everyone, so we're going to finish up our study of oblique triangles today, and we're going to talk about how to find the area of an oblique triangle. So when you were in geometry, you learned the very basic formula that to get the area of a triangle, you do 1/2 the base times the height. Well, we're going to study today what you do if you don't know the height of the triangle, but you know some of the other information. So there are some formulas on the page, and they're not difficult. It's just you have to know when to use which formula. So let's go right to it. So the first two examples talk about what to do if you're given a side, an angle, and a side. So it has to be that you're given two sides and the angle has to be in between the two sides. So let's take a look at number one. So we were given a number one that A is 90 centimeters, B is 52 centimeters, and the angle C is 102 degrees. So you have to make sure that this would really be side angle side before you get started. So let me just draw a quick little triangle. It doesn't need to be perfect at all, just to kind of see what we have. So we know A is 90 and B is 52 and angle C is 102. So yes, it is side, angle, side. The angle that we're given is definitely in between the two sides. So if that is the case, then we can use one of the three formulas that you see at the top of the page. So it's really the same formula, it's just rearranged depending on what information you're given in the problem. So I want to use the one that has the capital C in it so that I'd be able to put in the angle C is 102. So if you check out your three formulas, it says area is 1/2 AB times the sine of C. So that's the one I'm going to use. So this will be really easy. All you'll do is 1/2 times A, which is 90, times B, which is 52, times the sine of C, which is 102. Okay, so this is what we would need to calculate. So I'm going to go to the calculator now and see how that turns out. Not bad at all. Okay, so keep your calculator in degree mode. Hopefully it already is from earlier problems you were doing. So I'm going to do 1/2 times 90 times 52. Yeah, 52 times sine 102. And if I press enter, I get this. And as usual, we'll round our answer to the thousands place. So we would have 2,288.865. Okay, so the thing you have to remember about area is that you are supposed to give it in terms of square units. So when you write down your answer, be sure you do that. So it's 2288. What was it again? 865. And since our original measurements were centimeters, this would have to be centimeters squared. So that would be the area of our oblique triangle. Not bad at all. So number two is similar. It's just that we have different information that we're given. So for number two, let's see what happens. We've got B is 32 yards. And we have C is 73 yards. And we have angle A is, what is it? 64 degrees. Okay, so just a real quick check. If I were to make make a little sketch, I want to make sure it is side angle side real quick. So B would be 32, C would be 73, and A would be 64. So yes, this one is side angle side as well. As long as the angle is in between the two sides, you can use this formula. So you look at the three formulas, you want to pick the one that has angle A in it. So that one will just look slightly different than the original one that we were using before. So it will be 1/2 B times C times the sine of angle A. So all we're doing this time is 1/2 of 32 times 73 times the sine of 64. So I'm not going to put this one in the calculator since I just did the other one. So if you were to type this in, you would get 1049.791 in its yards squared, or square yards, because it's area. And that's it. So as long as you have side angle side, this would be the method to use, which is very easy. The other thing we're going to look at is what to do if you are given 3 sides. So that would be similar to number 3. So notice here it says that A is 43 meters. B is 53 meters. And C is 72 meters. So there is a formula, and it's called Herons Formula because there was a mathematician named Heron, and you know, generally when somebody finds something in math or discovers it, they name it after him. So that's why it's called Herons Formula. So it is this formula. There's a big square root symbol. There's an S, which I'll talk about in a sec, and then you do S minus A, S minus B, and S minus C. Okay, the S stands for the semi-perimeter. So in previous cases, when you've dealt with like a semicircle or semi-annual sale, that means that it happens twice or half the time. So semi-perimeter means half of the perimeter. So you know you find the perimeter of a figure by adding all the sides. So we would add A and B and C, and then half of it would mean to divide that answer by 2. Now, in order for this to work out in the calculator, it would be best to put this in parentheses when you type it in, so that way you don't have to do 2 separate things. So in our case, we would be doing parentheses, 43 plus 53 plus 72, and dividing by 2. So if you use the parentheses like I just showed and went to your calculator, you would get that this S value, the semi-perimeter, is 84. Now that's not the answer to the question. That's the number that you're going to use for the S all the way down in the formula. Everywhere there's an S, we're going to put in 84. So this is just a little bit longer, but it's not hard. So it's going to be the area is, there'll be a square root symbol. Let me move this over. I'm afraid I'm going to run out of space here. Okay, so it would be the square root of 84, and then it's 84 minus every one of these sides. So 84 minus 43, 84 minus 53, and lastly 84 minus 72. And you would type in exactly this on your calculator, which I will do real quick to make sure you see how to enter it. Okay, so just be careful because it is a long formula. So it's a square root symbol. We need the 84, the semi-perimeter, times, and then each one, 84 minus 43 times 84 minus 53 times 84 minus 72. And if you get one little parentheses in the wrong spot, of course, it messes everything up. So just be careful that you do it exactly like so. And that's what you should get. So rounded to the thousands place, I would say that's 1,131.887 if I round it. So the area on that one, let me write it down, 1131.8, what was it again? 887. And this is still area, so it should be meters squared. Final answer for number 3. Okay, just one more. And I know you're tempted to shut this video off because you think you got this, and you may not. So please stay with me. There's only one more, and this won't take very long. I'll be done in just a few minutes. So stay tight for just a sec. So A is 20, B is 33, and C is 56. So side, side, side. We don't need to draw the picture because we know that's 3 sides. So whenever you have side, 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 you use Herons Formula. But before you do, you have to get the semi-perimeter. So you're going to need to add 20 plus 33 plus 56, and then divide that answer by 2. So if you were to calculate this one, you would get 54.5. So it's not always going to be a whole number. It may be a decimal like this one. That's the semi-perimeter or half of the perimeter. Okay, so now we plug it into Herons Formula. So it's a square root sign, 54.5, and then you do 54.5 minus each side. And it doesn't really matter what order you do them in as long as you've got all 3 of them subtracted from the semi-perimeter. So I'm just going in the order of the problem. So this is what you would type in exactly on your calculator. So I'm going to do this one because it actually turns out slightly different than the other one that we just did. So let me go over here just one more time. And let's see what we got. So square root symbol, 54.5 times 54.5 minus, what were they, 20 is one of them. 54.5 minus, oops, gotta back up here. I put an extra 5. 54.5 minus 33. And one more, 54.5 minus 56. I keep plugging the wrong thing in there. Okay, so take that extra 6 off. All right, so that should be it. Yeah, all right, so when I press enter, notice what happens. It says error, non-real answer. So what does that mean? When we were doing square roots in the past, you were told that any negative number on the under a square root would bring in an imaginary number. So that's what happens here, is that we would have a negative number under the square root. So you can't see it anymore, but the very last one that we did was 54.5 minus 56. That would be a negative number. So that's giving you a negative under the radical, which is imaginary. So what does that mean as far as this triangle? Well, that means that this triangle that we were given doesn't really exist. So I explained that in the last video. Some of you didn't watch the whole thing, but what that means is that the triangle is not possible with those measurements. So if you were to construct a triangle and say you actually measured out 56 inches, or whatever it is, 20 inches, 33 inches, and then tried to make a triangle, what would happen is that one piece might be like too short to make the triangle. So maybe it would look like this. Or it could be that one piece is too long and it would be something like this, where it could not make a triangle. So it's either that one side is too short or too long. So whenever you get that number or that error message on the calculator about a non-real answer, that means that this triangle does not exist. Now, I actually knew before I tried this problem that that was going to happen, because I remember that there is a geometry rule, and I know you heard this before, but it's been a couple years ago. Here's a rule, and see if you remember it from your geometry teacher. It said that any 2 sides of a triangle, when you add them together, must be larger than the 3rd side. So if that doesn't sound familiar to you, you just forgot it since it's been a long time ago. So what I would do is say, well, what if I added 20 plus 33? That's 53, and that's not more than 56. So you could have told that that was going to happen before doing all this work. So try to remember that, and that might save you some time. So any 2 sides of a triangle, add them together, and that number must be larger than the 3rd side. So it's best to choose the smaller 2 numbers and see if it's larger than the longer side. Okay, so that's it, y'all. I hope you have a good day, and I'll see you next time. Bye-bye.